three-dimensional arrangement of the atoms that constitute a molecule. Heat of fusion is heat absorbed by a unit mass of a solid at its melting point in order to convert the solid into a liquid at the same temperature. The heat of fusion is equal to the heat of solidification. It is also measured in joules per grams. Boiling point is the temperature at which a liquid boils and turns to vapor. Its measurements are in Fahrenheit and degrees Celsius. The melting point is the temperature at which a given solid will melt. Its measurements are also in Fahrenheit and degrees Celsius. Hydrogen bonds is a chemical bond consisting of a hydrogen atom between two electronegative atoms. Examples are oxygen or nitrogen, with one side being a covalent bond and the other being an ionic bond.
Solute, the minor component in a solution. This can be explained also as in, say you have a bottle of water and a Gatorade packet. Just putting that in there, something that will dissolve it. Specific heat. The heat required to raise the temperature of the unit of a mass given substance by a given amount, usually 1 degree. It can also be calculated by using the specific heat formula, Q equals mc delta T. Vapor pressure. The pressure of a vapor in contact with its liquid or solid form. Polar covalent. A covalent bond in which the electrons are not shared equally, giving the bond some ionic character. Colloids. A homogeneous, non-crystalline substance consisting of large molecules or ultramicroscopic particles of one substance dispersed through a second substance.
Hey guys, I'm going to show you something about surface tension. Surface tension refers to water's ability to stick to itself. Surface tension can be measured and observed by dropping water onto a penny. The number of water drops that can fit on a penny will actually determine the surface tension of the water. Before starting the lab, you'll need to write a hypothesis, and you may want to create a table to record your observations. Our hypothesis is that if we add soap to the water, it'll make the surface tension of the water expand, making it harder for more drops to fit onto the penny than normal tap water. So we have our normal tap water, and we have soapy water. You're going to need a pipette and 1 or 2 pennies, whichever you'd rather prefer. And let's start with the tap water. You're going to fill that up, and you're just going to drop it on there, and make sure you count. Don't forget to count. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So far we have 20 drops, and if you can see, there's like a little dome of water over the penny, and it looks really cool. So 21, 22, 23, 24, 25, 26. Oh, okay. So we got to 26 drops on the tap water. And now we can do the soapy water. When you do the soapy water, you want to make sure that you don't get any suds, because it'll mess with the experiment. Just get underneath in the actual water. Okay. 1, 2, 3, 4, come on, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, okay, so there were 13 drops on the soapy water. So that proves that our hypothesis was correct. So the surface tension of the soapy water was less than the surface tension of the tap water. Alright.
Alright, I'm going to show you guys how water is a universal solvent. Now first, a universal solvent is anything that can dissolve a solid, liquid, or gas inside of itself. Water is a prime example of this universal solvent. Now here we have a bottle of water and a packet of Gatorade. Now if I put this into like corn syrup or something, all you'd see is just a bunch of powder and some corn syrup. But you'll see as I put it into water and it overfills, it spills everywhere. It's already pretty much, there you go, it's all mixed, it is dissolved into the water, the universal solvent.
Today we will be talking about the boiling point of water. As we all know, water boils at 100 degrees Celsius, and that's what we're going to be proving today. So first off, you'll need a Bunsen burner or a stove, a beaker or a pot, and a temperature probe or a thermometer. So now that we have all that together, we need to start heating up the water, which we already did, and as you can see, it's already bubbling. So once you see it bubbling and steaming up, just put in the thermometer, and as we wait, it'll slowly get up to 100 degrees Celsius.
And when you fall, feel me. You'll see my face on the back.